as though from the sound of the rumbling, we're at least on number 3 and either have done it correctly or are a little confused. So let's start with question 1. And again, these 4 questions have been released by AP. They were on a former test, and so they, have gone through that process. I'm not sure you know what that means, but there's a process by which each question is written, and it's evaluated by I think 2 or 3 different committees that it's put into a test situation, and they test to see how people do on it, and then they actually put it in and make it count. That makes any sense. So it's a whole process a question has to go through, which is why they don't release many multiple choice questions, because the bank's not that big. Does that make sense? Like, they reuse questions from time to time. So anyhow, here's question 1, okay? We have some points labeled specifically. We know it's bivariate data. So they have labeled them X and Y on these scales. Preferably should really be in context, in a contextual situation. Hopefully you're labeling your axes. Hopefully on your scatter plot for the Monopoly assignment, you labeled cost and spaces from go, because I'm looking for that on your scatter plot. So always want to make sure your axes are labeled. So here we have, we're looking for the largest residual. And when we think about the largest residual, and it's a graph, a scatter plot here, what am I looking for? Devin?
The plot with the longest distance away from the line.
Okay, the largest vertical distance away from the line of best fit. And so I'm just going to kind of draw those in, just so we can kind of see what they are. And hopefully one sticks out as being the furthest away. It can be negative or positive, but in this case, it's going to be positive, so the answer would be A. Zachary.
You're trying to find the largest residual, right?
Which would be the longest vertical line.
But isn't it the farther away from the residual, the closer to 0 it is?
No. A residual is the observed minus the predicted. The observed is the actual point A, B, C, or D, and the predicted is the line of best fit. So an actual residual is just that. It's a distance away from the line of best fit. Mm-hmm. Yes. So this would in this particular case, well, it would have to be a positive anyway, right? So we can kind of eliminate answer choice D for that very reason. Okay. The residual would be a big negative, but I guess in terms of the largest, you see what I'm saying? Like, it's not the absolute value, if that's what you're asking me. Okay, so it's not. You will have some negative residuals. Huh? I don't know. They could. That's a good point, though. Do you understand what his question is? He said, well, the residual is not the absolute value. You definitely will have some negative values and some positive values. So it's important to, couldn't we just eliminate answer choice D because it's negative, so we know it's not the largest. Negative numbers are small, right? But really what this is asking is how far away from the line of best fit it is. So we could, I guess, eliminate answer choice D for that reason, but yes. So if, let's say we had a point F down here, I think is what he's asking, would F be the largest residual? And I think the answer to that is no, because it's a large negative number, which means it's the very smallest residual. But I think the point is, and so that's where we got into the absolute value. If it was absolute value, then F would be the largest residual. Okay, but it's not, residuals are positive or negative. Okay, yes? Let's see where C is. I didn't see C, hang on. Is there a C? Yeah. Oh, here, yes. C would be negative residual, and as well would D. D is like on it here. It's a little bit below, looks to me like. And then C is definitely below the line. Yes. Evie?
What was the question? Then what if the question was, what was the smallest residual?
So I think that's what the point is, and I don't think that they're not going to try to trick you in that sense, okay? That's not the point. I think it was just so I wouldn't think they would ever do that, because it's really the point of a residual is to know that it's further away from the line of best fit. Okay, the questions I have seen in regards to this definitely talk about, I've seen this question obviously, I've seen where they talk about which one has a positive residual, which one has a negative residual, so they will specifically talk about direction. So it's important to know that ones below the line are negative residuals and the ones above the line are positive. Okay, that's kind of the theme there. Okay, let's go on to question 2. This one should be a real easy one, shouldn't it? Because we've done this before. So what do you think here? Sammy, Banane? Yeah, okay. Correlation of -1, it's exactly -1, which means every single point has to be on the line. That's A. Quick, move on. Again, some very easy questions. This one takes a lot of time. We'll come back. Let's look at question 4. Okay. Again, a bivariate situation. I like this scatter plot a little bit better because it has variables, year and percent of games won. And honestly, they have this whole paragraph that explains the graph, explains the relationship between the variables, gives you some context to the situation. But I have this point down here circled. Okay. First of all, is that point an outlier or a hang on, let me answer the question, ask the question first. Is it an outlier or is it, what's the other point? Influential point. Which one is it? It's an influential point because it's not in the data set. Remember, outliers are within the data set and are far away. So here is the actual given data values, right? No, I didn't. Go back and look at your notes, okay? Inside here, far away, that would be an outlier, right? Outside is an influential point. Not that it really matters too much. I don't think they're that picky on the AP exam, but I think Ms. Meckert might be a little picky on her test or a quiz, hint, hint, that you have coming up next class, okay? All right, so let's look at the circled point. And let's see what the question's asking, and let's kind of get a feel for it. It's definitely away from the other data values. And it's going to do something, if we include this point into the data, it's going to make the line of best fit come towards it. Would you agree with that? So I think the question's asking, what is it going to do? So let's make sure that's what it says, okay? It says the point will make the regression line steeper. Okay, let's see if that's true. Let's kind of just draw what it might look like. It's getting pulled towards it. Would you agree with that? Is the line steeper? Okay, so that part's true for answer choice A. But let's keep going. And it will make the correlation coefficient stronger. No, it's actually going to make it weaker. Why? Because the majority of the data is where it is now. So it's moving the line away from the majority of the data, therefore weakening the correlation. So that we can cross that answer choice out. And when we look at multiple choice questions, that's one of the strategies I want you to do. I want you to eliminate answer choices. Okay? Let's look at answer choice B. It's going to make it steeper. We agree with steeper, don't we? Yes. And then the correlation coefficient weaker. Yeah, I think that's the answer. Okay, so I think that's the answer. We should go through the other choices just to make sure. It's going to make it closer to the horizontal. Nope, that's not true. Make it line closer to horizontal. No. The last one will have no effect. I believe it has an effect, right? So answer choice B seems like the most reasonable choice. This question was pretty heavily missed on the AP exam that it was on, okay? Probably because I think some kids look at the wording of the question and just skip it. I don't know, question A. Okay, so really it's not hard if you just kind of look at the graph and look at what's asking you to do. Okay, and honestly, I didn't even read the question, did I? I went straight to the answers and was able to answer the question. Probably shouldn't do that. Probably should read the question. Right. Yeah, that would be a problem. That had the word not. Right? Which one is not right? That would be an issue. Okay. Let's go back to 3. And I think I've seen some people already answer question 3 correctly. Did you have an issue, Temerson? I don't mind. I can pause to this. So we have a lot of information here, okay? We have some points here. We're given some mean and standard deviations. So I'm going to kind of highlight some important things. The mean of x is 5. The mean of y is 10. I'm also told that the standard deviation of x is 4 and the standard deviation of y is 10. If you are ever given those things to you, you should instantly think of what? The formulas on your formula sheet, okay? Because those are the values that are given. So you have your formula sheet there. You should have it out, okay? So let's write down the formulas, the three formulas that we've used up to this point. Okay, what do we have? I'm going to borrow Daniel's because I don't have them memorized, and you don't need to memorize them either. But we have this formula here, and you have this one. I always put parentheses around my fraction just because I'm so used to it, but I know that not many of, I know it's not written that way on your formula sheet. Okay, thank you, dear. So we have some information here, okay? We have SY, SX, so we have this information. We also, from given in the problem, we also, if we look at our answer choices, can figure out this number. What is B1 again? Is it the slope or the y-intercept? Okay, it's the number with the x, so it's the slope. So I'm just going to highlight the slopes in each of those cases. So why do you think that I could use what's highlighted in yellow here to help us make a decision and possibly eliminate some of those answer choices? Temerson? Uh-huh. And solve for what? R, the missing variable. And what do I know R has to be between? 1 and -1. So if it's outside of those values, then I can eliminate that as a possible answer choice. Okay? So I want you to try that and try, because don't A and B have the same slope? Go ahead and plug in the 3. Show me what you get. So you have the slope is equal to R times SY over SX. Tell me what you get for R here. What is the correlation? Or what would the correlation be if the slope was 3? 1.2. Is that possible? No. Erica, I lost you. Because the 3 is the slope. I'm looking at these two possible as answer choices. I'm going through my answers now. Okay? I got 1.2. Do we know how to solve this for R, right? Multiply by the reciprocal, both sides. Okay. 3 times 4/10. Just to solve for our correlate. Whoop, throwing things at you. So I have 3 times 4/10, and we do get 1.2. That makes no sense because your correlation has to be between 1 and -1. So what can I do with answer choices A and B? They're not the right ones. I can cross them off. I've eliminated, Tanner, 2 of my 5 answer choices. You should be writing this down. You guys have a test. You're not even on the right problem. Turn it over. Question 3. Well, you are on the right problem, a total liar. But you have the wrong question, wrong one highlighted. Okay, so you should be writing down what I'm writing down. So let's go ahead and look at some of the others. What are some other strategies? I could go through and answer choice C, D, and E, and they would all have correlations that would work. Okay? They would all have correlations that were between 1 and -1. So you can trust me on that, or you can test it yourself. That's okay. But they all would be possible correct answers. Yes? Because I used this formula, and I plugged in SY over SX. I plugged 10 over 4. That was given to me up here. And then I chose 3 to be my slope, because that's what the slope was in answer choices A and B. Yes. And then what I just said was that I just trust me in the fact that the R would work. It would give you a reasonable number, somewhere between 1 and -1. The only correlation that wouldn't work would be A and B. Okay? So now I've at least eliminated 2 of the 5 answer choices. So now I've got to figure out a different strategy. I need to eliminate more, or at least find the right answer. There's one thing I didn't tell you about line of best fit. This is a good place for this to come into play. The point X bar, Y bar is actually on the line of best fit. That's pretty important. So let me say that. X bar, the point X bar, Y bar, okay, it's the mean of the X's and the mean of the Y's. It's actually on the line of best fit. So we could literally plug in the number for x bar. We can plug in 5 for x, 10 for y, and see which one it satisfies. That's one possibility. Jordan. Yep. Yep. There's more than one way to approach this at this point, but you're exactly right. I could now move on to this guy, right, and plug in what I know and see if I get the right slope out. I'm sorry, the right y-intercept out. Yeah. And then that would be a different way to do it. Okay, but either one works. So I'm going to pause the recording for a minute. I want you guys to figure out, is it C, D, or E? Which one is the answer? I'm checking answer choice C. I have that the y-intercept is 5, the y-bar is 10, the slope the slope is 2.5, and the x-bar was 5. Is this a true statement? No, it's not. Okay, 10 minus 2.5 times 5 is not 5. Doesn't work, right? So we can cross off answer choice C. It doesn't work. Okay, let's keep going. Do you see how long this problem takes? Which values? I use this formula here. This 5 is the y-intercept for answer choice C. This x-bar and y-bar was given to me in the problem. And this slope is the slope here in answer choice C. I'm just plugging in the numbers from what's given to me, and I'm just going through methodically and checking each of my answers. That's all. I checked A and B here. I found out that A and B did not work. Here I used a different formula, but checked and C does not work either. So now I got a 50-50 shot in getting the question right. So let's figure out which one it is, D or E. Okay. So answer choice D is the correct answer here. Okay. So here are, now remember, your test is half multiple choice, half free response. So here are 4 practice multiple choice questions. You probably won't see them exactly like this, okay? But you have, this is the kind of level of questioning, kind of thought process I want you guys to be thinking about. If you go ahead and look at the last page of what I've given you here, okay, bless you, which is a released question from the AP exam in 2006. Oh, wrong thing, sorry. It's a practice. The released questions on the other side. Now, we need to talk about what we call computer printout, okay, computer data that's given to us. Because AP realizes that every school cannot have access to very expensive statistical software, then all they really want us to do is to be able to analyze the output of what the statistical software would actually create. So if you in your book on page 188, if you have your book handy, you can get that out and look at it. But on page 188 of your textbook, there is also another example of a computer printout. If you don't have it now, you can look at it when you get home, and that's fine. But it tells you where to find the things that you need to write the equation of the line of best fit. So I've written it here for you as well. You will, I guarantee you, have a computer printout on either your quiz next class or your test at the end of the unit, or both. So you can expect to be able to have to use a computer printout. Okay, they do it all the time on the AP exam. So really, if I'm looking for the equation of the line of best fit, what information do I need? Slope and y-intercept. That's all I need. In every computer printout, I shouldn't say everyone, but almost all of them will have those two things. Okay? You'll notice here that they are underneath the coefficient column. And then you have your constant coefficient. That makes sense that that's the y-intercept, doesn't it? Constant coefficient. And then your coefficient of the other variable, which in this case was time, is going to be the slope. Okay? If you look at the computer printout on page 188, it doesn't say COF. It actually says the column as coefficient, doesn't it? So either way, either COEFF or coefficient written out, that column The constant is going to be your y-intercept, and the other variable, and it's always given to you in context. This one was time. The one in the book, I believe, is protein. So whatever that variable is, that's going to be your slope. Okay? So based on this, and this is what we need to practice, is I want you to think about the context of this situation. And Devin and I were having a little conversation about this. So I'd like for you to read this paragraph and think about what this information, and kind of wrap your brain around the meaning behind the numbers for just a second, just the slope and the y-intercept. So here we have some toddlers, and we're based on several months at a nursery school, the time they spent at the table, and the actual calories that were consumed. Okay? So we want to think about toddlers, okay, and after a certain amount of time, they're probably not they're going to stop eating. I don't know if you guys have little brothers or sisters, but I know all three of my children, when they were done, they started feeding the dog, throwing food on the floor and whatever, right? So the amount of calories that are consumed after a certain amount of time is probably different than in the beginning. Wouldn't you agree? Okay, so we got to think about that situation. So let's scroll down. You should be writing this down. What is the equation in context? So what is our y variable in this case? Calories consumed. Okay, so you want to say calories hat equals, and then we're actually going to plug in the numbers for the slope and the y-intercept. Okay, so we're going to go ahead and write our y-intercept to be 560.65 plus, or I guess it's minus, right? Minus 3.0771, and then what is the x variable in context? Time. Okay? Okay. All right, so, yes?
I don't understand.
Right, so I think letter B is going to help us with that. Okay? Yes?
Would it be better since it says the time in minutes not to say for the time, say minutes of time?
That's fine, either one. Yeah, so minutes here. Is that what you're saying? That's totally fine. Time, as long as it's contextual, it's fine. So I think part B is where we need to wrap our brains around this. Okay, so we have to figure out the meaning of the slope in the context of the problem, and the meaning of the y-intercept in the context of the problem. Okay, so I think what we need to think about is if the y-intercept is 560 calories, right? That's the y-intercept. This data is probably mirroring something after they stopped eating, wouldn't you think? Because the y-intercept is kind of like the starting point, right? Think about your Monopoly problem. It was the price of go, wasn't it? That in the context, that's what you should have said. The y-intercept was the price of go, even though it's not really a thing. That's what it would, in theory, be. So what the y-intercept in the context of the problem is the number of calories a toddler started with. Okay, so they ate 560 calories over time. That's what they started doing. Okay, so you can kind of think about, for a while, when you sat them down at the table, they ate, and then at some point they stopped eating, right? And at that point they stopped eating, what'd they do with the food? Threw it on the floor, right? Threw it at Miss Mackert, whatever, gave it to the dog. Now we have negative calories going on, don't we? We're getting rid of stuff. So now we have a different model. We have a different train of thought. The line changed. So I'm thinking that this data is actually modeling this situation, okay? So we are starting at the 560 calories up here as our y-intercept, and then we're going down. For every minute, we have lost 3 calories. Are we okay with what I'm saying? I think that the hard part is that when we think about eating over time, you would think the more time, the more calories you eat, right? So that's why you have to think about, well, let's look at this problem. And if it was on my test, I would have said that and been a little bit more clear, okay? This is an actual practice problem from the textbook. But because we know we have a negative slope, we know that it has to be, and we have a correlation coefficient, I'm sorry, not a correlation, a y-intercept of 560, then this has to be the data modeled after that point where they stopped eating. Okay? Are we okay with that now? Devin, a little bit better? Still not better. Okay. This equation is modeling the yellow portion of the data. So we have some toddlers that are eating, and then they stop. And now we're not eating anymore. And now we're getting rid of. Yes. Yes. And that I don't think is clear in the problem. And I agree with you. I don't think it is. Yes. Yes, and so let me show you, let me write down what I would expect you to say, okay? So in this particular problem, this meaning of, let's do the y-intercept first, is that okay? Because I think that's, to me, a little bit easier to understand. But they eat, so toddlers start with 560 calories. That is the starting point. That is the y-intercept. That is, if I'm thinking about the axis here, okay, that is this value. Okay, they started at 560 calories. That's what they start with. That's the amount of calories they start with. They've eaten something beforehand. Now we have 560 calories in our bellies. Now what are we going to do? I'm going to start throwing food. Okay? So, part B, what is the meaning of the slope in this particular context? We need to make sure that we realize the slope of this is this number. We're going to put it over 1. Let's put the variables in there as well. We know that it's y over x. Remember, slope is the difference in y over the difference in x. What is the y variable here? Calories. And what is the x variable? Minutes or time. So what we could say is, after 560 calories, they're going to lose 3 calories for every minute. Yes, no, maybe so? Honestly, if you can't wrap your brain around what's happening in terms of the piecewise defined function over here, don't worry about that. Okay, I really don't. That's not, you probably won't ever see that again. What I am concerned about is, can you put the x and y variable in the context with the slope? They are losing 3 calories for every 1 minute. When I say interpret the slope, that's what I mean. Can you look in the printout and find the slope number? Yes. You know where it is. You know to put it in context by saying the words, you lose because of the negative 3 calories for every 1 minute. Yes, Sammy. The slope will, I hate the word always, so I'm never going to say that. The slope is always in the coefficient column next to the variable that's given. Okay? Can we interpret the slope and the meaning? Let's think about the monopoly problem for a minute. Yes. Okay, that's always your slope, right? Let's think about your monopoly. What was the slope in the monopoly problem? Let me look back at it. Hang on. What was it? Da-da-da, where's my slope? Here. Where's my key? Can you grab it for me? Thank you, thank you. Okay. All right. Shh. So monopoly problem. Sometimes this one might be a little bit easier. Okay, in the monopoly problem, here was my equation. Whoa. We have cost of the property was equal to 67.28 plus 6.78, and that was spaces from go, right? So that is what you should have written as your equation. Let's interpret, to make sure we understand, because you're going to be asked to do this on your quiz next class, let's interpret the slope and the y-intercept. Okay? Let's interpret the y-intercept right now. The y-intercept is where x is 0. It's where there are 0 spaces from go. So what does that mean? What space am I on? I'm on go. So what does that mean that 67.28 is? The cost of go. Okay? And obviously that would be a hypothetical situation. Would you agree? Okay, because it's really not $67. Now, let's interpret the slope, 6.78. Let's put it over 1, and let's put our variables in there. What's the y variable? Cost. What's the x variable? Spaces from go. Okay, so we'd have to say approximately here because we have decimals, wouldn't you say? Oh, actually, we'd have to round to the nearest cent. I guess that would make the most sense, right? So how would I write a sentence to interpret this? Or how did you write your sentence to interpret, Charles?
I would write the cost of each space increases by $6.78.
Yes. So if every space away from go that you go, the property value increases by $6.78. Agreed. And obviously, is that exactly true? No, but it's the rate at which the growth happens. Yes. Are you sure? It's the second time you've done that to me today. Okay, yes. Jordan. For the slope, no, you don't have to. Okay? So the cost of each property increases by $6.78 for each additional space from go. Now, to kind of back on what Jordan asked, we also know that the cost of go was $67.28, right? Now, we know that the properties on Monopoly don't go up exactly by this much, okay? But when you did your scatter plot, you should have found that some are close to the line of best fit, and you did find some values that were away from it. What properties were those, by the way? The railroads. Because the railroads, no matter how far you are away from go, are always $200. Oh, and the utilities as well. Utilities and the railroads should have been far away from, like, kind of like, I guess they went away across the scatter plot looking like this, maybe. Was one of them close? Yeah. The furthest one, was it electric company? I forget which one. Waterworks is the one that's far away. Okay. Do you think you could do this? Find your y variable, find your x variable, and just write a sentence. That's all you have to do. Okay? You laugh, like, hysterically? Is it okay? Okay. Okay, so let's go back to the free response part here. Okay, so let's scroll down. For D, find the value of the correlation. Okay, now we need to talk about where is the correlation in this computer printout. It's not given to us. What is given to us? R squared. And we're going to talk about R squared here for the last half of class. But I can find R by simply taking the square root of R squared. But you need to put the percent as a decimal. So you need to say 0.421 and take the square root of it. So I know that if R squared is 42.1%, R is the square root of 0.421. Okay? So it's negative? Oh, that is a good point. I didn't even think about that. Yeah. Thank you. Right. Yeah, so he's exactly right. So let me do this real quick. Yep, he's exactly right. 0.421. So it is negative 0.65. Because when you square a negative, it becomes a positive. You have to take that into consideration. How did I know that the correlation was negative? Slope's negative. So those should match. Okay, so exactly good, very good point. Okay? The R squared meaning. Here we go. You ready? The meaning of the correlation, don't worry about it. Just find the correlation. I want you to find the meaning of R squared. Because that is what you have to do on your investigative task, correct? You have to write a sentence about what R squared is. R and R squared are both on your calculator. They give you those numbers on your calculator. What does R squared mean? So, what the heck is R squared? Here we go. R squared is called the coefficient of determination. Okay? It's written right here, I believe. Oh, it's not. Darn it. Here are some facts about what R squared is. Okay? R squared is literally the square of your correlation coefficient. It's the square of R. You go back and forth between them mathematically, just like you would have to put the negative if the slope was negative, like we just did. Square root to go back and forth. Okay? So this is what the important sentence is. R squared gives us a percent, so you'll always have to convert to a percent. Okay? Move your decimal place. It gives us the percent of variability. Now hang on. I'm going to stop after every word. Variability. What is meant by variability? Think about a scatter plot. Any scatter plot. If every single point is on it, the variability is, okay? But if there are some points above and below, there's going to be some variability in the data. It doesn't exactly fit the line of best fit, right? So this percent is the percent of variability of whatever your y variable is that's accounted for by the regression relationship with x. So you are literally, if I'm going to, so you're going to say, I don't think you have to interpret R squared on your investigative task. I think you just have to give it. Because I don't think on your investigative task, there are no context variables, right? It's just x and y. But on your quiz, you would have to interpret. So what kind of thing I want you to do is literally write the following sentence. R squared. Write the percent here of variability of blank. Put your y variable in there. That is accounted for or explained by and put in your x variable. If you are ever asked to interpret R squared, this is your sentence. You're going to plug in 3 things, and they all have to be in context. You're going to put in whatever the R squared value is, the percent. You're going to plug in whatever the context y value is, and not the value, but the variable. These are variable names. Time, cost, spaces from go. You're going to put the context here. Charles, you had a question, darling?
I didn't hear what you said. Did you ever say what accounted for by the regression relationship that segment?
These 2 things mean the same thing. Okay? I like explained by better than the regression relationship with x. What's highlighted in yellow and what I wrote in green are really the same sentence. Okay? I think explained by is better. Okay? Personally. Basically, what it gives you is how good is our model. Okay, it's another piece of the data. Is the data linear, yes or no? Okay, so the correlation is how good, if it's between 1 and -1, or if it's close to 1 or -1, then it's a successful model. If you square that, that really talks about how good the model is. It's giving a percent now. It's giving us either a really strong percentage of the value that's of your y's that you can explain by whatever your x was.
Would it be better for R squared to be close to 0?
Okay, good question. Do you want R squared to be close to 0? You want it to be close. So if your correlation is 1, for example, or let's say 0.99. So let's just kind of look at it from a mathematical standpoint. If you have 0.99 as your correlation, and I square that number, 98% of the data is explained. So we want that. A good correlation means a strong, close to 100%. Okay? Are we okay with what he asked? It's a really good question. You want your data to be explained. You want the relationship for y and x to be explained to each other. Okay? You want one to be responsible to the other. So you want this, I'll even write this down, you want this to be as close to 100% as possible. Okay, good point. Does this help you with the rest of your investigative task? Hopefully. Okay, all you have to do is square. I think the calculator even gives you R-squared. Yes? I'm not even calling you anymore. Third time. No, ask it. If you have it, somebody else in the class has it. Go ahead.
Okay, well, data set A,
Uh-huh.
R squared,
Uh-huh.
I have 0.645.
Okay, so you would say 64.5% of the variability of, you have to just say y because we have no context, is explained by x. And that's all you would say.
I know, but for my data set B,
Uh-huh.
0.66.
You're going to have different r values for each one of them.
Yeah, they're close, but like on the graph, they don't like look the same.
Right. That's why. Okay, so this is a great question, and I'm so glad you asked it. So he has a similar correlation and a similar R squared for several of his data sets in the investigative task. You should. And the graphs are going to look entirely different, right? So what that means is that your correlation alone is not enough to say whether the data is linear. Remember what you're doing on your investigative task. You are answering the following question. Is the data linear? That's what you're asking, right? And what are you going to answer with? Yes or no? Because, and you're going to give me three things. It's linear, yes, because. Give me one of the things I'm looking at to answer that question. The scatter plot, okay? You're going to say that the scatter plot shows a linear pattern if it's a yes, or if it's a no, you're going to say no because the scatter plot doesn't look linear. It looks like, I don't know, a V shape, or it looks like exponential, or whatever. Okay, I'm going to keep going. The second thing you have to say, in each data set, you're going to have to say, data set A, yes, it's linear because. Data set B, yes, it's linear because. Data set C, no, it's not because. Oh, yeah, thank you. Residual plot could be second. Let's look at that. Okay, what do we expect the residual plot to look like if the answer is yes? Let's circle yes. Scatter plot must look linear. How about the residual plot? No pattern. Okay, so you better have, if you're going to answer yes here, that it's linear, your residual plot had better be completely scattered. What's the third thing I'm going to look at? Correlation. Okay, and you want it to be close to either 1 or -1, right? So correlation alone, you should be finding out, is not enough. Because Temerson said that he got R to be close in two different cases. Well, that alone should tell you that you have to look at the scatter plots and the residual plots as well. I'm glad you asked that question. It's a perfect question. Erica.
Yes, you said that the residual plot has to have no pattern.
That's right.
Scatter plot must be linear.
Yes. Exactly. And then that has to happen too. Then it would be you would have a patterned residual plot. You would scatter plot might look like I don't know what it's going to look like, but it's not going to be linear. And then your R is going to be not as close to 1 or -1. All three of those pieces have to be combined to answer that question. Did you have a hand up?
Yeah, well, the actual investigative task is right on the R-squared.
Yes, please. Yes, please. Even though you're plugging in Y and X every time, yes. Devin. Shh.
When the correlation is actually 1 or -1.
When it's exactly 1 or -1, every data value falls on the line.
Right, then the residual plot would be a line.
Yes.
Doesn't a few of them for the investigative task it give a line for them?
Not a horizontal line, though.
No, but
Yeah, it still has a pattern, though. So I agree with you. If it's exactly 1 or -1, the residual plot's going to be a horizontal line at 0. I agree. But that's not going to happen in this case. That's like the, how often is that really going to happen? Very, very rarely. But yes, you're right. It's for the most, anything but a horizontal pattern has that.
if it is a horizontal line.
Yeah,
I'm not going to give that question to you, okay? So I'm not going to give you one where every single data value falls exactly on the line of best fit. That's just such a rare case, it's probably really never going to happen. Okay? You should not have any horizontal residual plots, period, on any of these. Okay? So that should answer that question. You should have some definite patterns, though. Okay? Some definite patterns. So what do you have to worry about for next time? Because I need to send you, Isaiah, to Ms. Harris, right? You need to realize you have a quiz next class. Okay? And the quiz is on everything we've done with bivariate data so far. It's on chapters 7 and 8. I have not officially assigned problems from chapter 8, but I will next class. After the quiz, we'll work on some of those. So if I were you, I would definitely make sure, and we have talked about everything in chapter 8, we just haven't officially done textbook problems for it yet. But you do have a quiz next class. It will be on chapter 7 and 8, correlation, residual plots, line of best fit, formulas, knowing your and you can use your formula sheet, just don't write on it, okay? And then you have your investigative task due, which you should have mostly done already, okay?